In this video, I'm going to focus on quadratic functions. On the first question of the test, we were matching linear functions, quadratic function, and exponential function types with the corresponding equation. And so you have a one-page summary, and I have pulled out just the quadratic part. And when you look at an equation for a quadratic function, you'll note that there's always something squared. It has an exponent of 2. So when you're looking in your list, you're looking for things that have an exponent of 2. So I can see that I have an exponent of 2 right there. And I have an exponent, but it's not 2. No exponents here. Exponent, but not 2. No exponents here. So I only have 1. So this first one is the only one that would be a quadratic function. For the second question on the graph, or on the test, you had to match graphs with the correct function type. And again, it was linear, quadratic, and exponential. So we're focusing on quadratics this time. So I'm going to look again at my one-page summary, but I'm going to focus just on the quadratic section, which is right here. And I can see I have 2 graphs on my summary, and they're both curves. And that is true. One of the key characteristics of a quadratic function is that there's a turning point. We call that turning point a vertex. So we need to look at a graph that is curved and has a turning point. And so this is curved, but it's always decreasing. There's no turning point. It doesn't change direction. So we need a complete direction change. This has a quadratic. This is quadratic because it has a turning point with a change in direction. I'm increasing until the turning point. Now I'm decreasing or going downhill. This is constant. This is constant. This one, again, you can see is changing, and it's going from decreasing to increasing. So I know that that is quadratic. Next, we're going to look at the next question in our test that had a quadratic. And again, I know this is quadratic because I see that squared. And I want to refer back to my one-page summary. And I want to look at what do I know about quadratics here. I'm going to match this up with my equation y equals a times the quantity x minus h squared plus k. I see that I have a negative out in front, and that goes with my a value. A value tells you whether you open up or down, and if it's positive, it's opening up, and if it's negative, it's opening down. So I can see that my a value is negative. And I can see I have 3 graphs that are opening down, and I have 1 that's opening up, so I can cross off the one that's opening up. Just a quick note here that your choices may be scrambled up and different than mine. So keep a look at the key characteristics that we're talking about and not just the letter number or the letter marker. I want to continue looking at my equation, and I want to see what the h and k are. I notice that I don't have parentheses in this equation, which probably means that my h is 0. We can rewrite this so it more completely matches our full vertex form. So if I rewrite this, I can make that negative out in front as -1 times my x squared value. And x squared is the same thing as x minus 0 squared, where my h value is 0, because x minus 0 is still x, and that's still being squared. If I multiply that by -1, it's still negative x squared. So I haven't changed the value, but now I can see more concretely that my h value is 0 and that my k value is 6. So I haven't changed the value. I just rewrote this in a way that I can really see how things line up. So I can see that my vertex should be 0, 6, taken right from my equation, my h and my k. So now I need to look at my graph and see where is the point 0, 6 for a turning point. So 0, 6 means it's not going left or right at all, it's going up 6. So this right here would be my choice. If I look at this one right here, this is 6, 0. And this one over here is -6, 0. Here's another quadratic question from our graph. and we have to or from our test, and we have to match the graph with its correct equation. And so the first thing I like to do is see that it opens up. So that means A is positive. And I want to look at where my vertex is, because my vertex is the HK. And in this case, this point right here is my vertex, which is at 3, because it's 3 over this way, and it's down 5, so that's -5. And now I can look at which of these equations is going to match up. So remember, this is the general form here, and we know our H is 3 and our K is -5, and we know that our A value is positive. All of our A values here are positive, so that doesn't rule out any of our choices. So we're looking at A x minus the H value. So here's my HK, so it's going to be x minus 3 quantity squared, and then plus -5. And adding a -5 is the same thing as subtracting 5. So I have this negative here. These are both positive. I can rule out those choices. So now I'm looking at these two, and it's x minus 3 when I use a positive 3 from my vertex. So this choice A is our winner. Is this, that's not true. B is our winner because it has the minus here. So because this is an addition, and it is not our choice. Again, keep in mind, I got that equation from my one-page summary or referring back to other notes. Now I'm looking at another quadratic function, and I know it's quadratic again because I have that change in direction. I have a U-shaped curve, and we are wanting to write the equation. It's an open response, free response, where we have to generate that equation on our own based on this graph. And again, when we are given the graph, we can look at this right here. When we're given the graph, what do we know? We can find the vertex from our graph, which tells us our H and K value, and we can tell us whether our graph opens up or down, which tells us something about the A value. Then we can write our equation. So in this case, my vertex is right here, which is at 3, 5. So 3 here, 5 there. So that's my ordered pair, which tells me that my H is 3 and my K is 5. My parabola opens down, which tells me that my A is negative. And this is our standard shape here. It's going to the left one, down one, right one, down one, just like our parent function does. So I know that that's going to be 1. So this is our general form here. Y equals A times the quantity x minus h squared plus k. And we have those values up here to plug in. That is going to be y equals -1, or you can just put a negative there. X minus my h value, which is 3. Close my parentheses. That squared makes this a quadratic equation, plus my k value, which is 5. So this equation will be the correct equation. You could also write this as just negative parenthesis for the around that quantity, x minus 3 squared plus 5. Either would be correct for that. Finally, we're looking at our open response graphing section. So we're given an equation, and now we need to graph it. And I know, again, this is quadratic because it has my equation with an exponent that is a 2. It's being squared. And so let's take a look. Given an equation, what do? We're looking at our one-page summary again. I'm looking at just the quadratic section. You see labeled there. And I know that, what do we know? We can look at the A value to say whether it goes up or down. We can look at the HK value from the equation and write that as a vertex, and then use that information to plot it. So in my equation, I don't have a number out here, so remember that 1 is that implied value because 1 times anything is itself, so it doesn't change the value. So my A value is 1. It's positive, so I know my parabola should open up. My H value, so remember my equation is supposed to be x minus h. So this needs to be x minus something being squared. And if it's x minus something, it can't be minus 3. It couldn't be 3 because then I would plug that in and I get x minus 3, which is not the same as x plus 3. But it could be negative 3. X minus a negative 3 is the same thing as x plus 3. And so I know my h value is negative 3. Out here, I should have plus k, so that's going to be plus a negative 5. So I know my k value is negative 5. And that means my vertex is negative 3, negative 5. The next thing we do is we plot that. So remember, this is our x-axis. This is our y-axis. Negative 3, negative 5 would be right here. And my parabola should be opening up. If you do not know how to do your remaining points, you could still be proficient to just graph that U shape going up. But you can look at our summary notes here, our one-page summary, to see that basic shape of going over 1, up 1. When our A value is 1, just like it is in our example here, it is on our paper. So that shape is going to be the same. And if I go out again, if I go out 2 units, it's going to be up 4 units. So you can use that basic shape. You can also look in your notebook where you have lots of tables on page 101 to 103. So I've sketched in those values. And remember that because this is symmetric, we have these mirror points. So you know that those will be the same. And so we get this nice U-shaped curve. You could also do a table of values and plug those in. And we would have negative 3, negative 5 in the center. And you would pick 2 numbers to the left, like negative 4 and negative 5, and 2 points to the right, negative 2 and negative 1. Or I should have said negative 4 and negative 5, I think. And plug those in to this original equation and solve for the y values. And plotting these distinct points are going to take your understanding on this standard to an expert level.